Hello, Daryl here. The channel is Programming in Any Language. Supporting website is programminginanylanguage.com or black-duck.com. They both take you to the same place, and it's a place where you'll find the videos and the PDFs of the code. The video is identifying classes in a problem. You know how to code a class, but what should be a class? That is sometimes a very difficult thing to identify. Well, this video will help simplify that process. And the key here is understanding what the problem actually is. If you do not understand the problem, it is very difficult to create classes that will help solve the problem. Take a look. Now we've got a good idea to how to make classes in our programs. What should be a class? That's the big question here. How do we know what to make a class? It's kind of interesting here because there's a way to do this that also is very similar to how you would define tables in a database. So the concepts here are the same. I learned the database piece first, and when I was working with object-oriented programming, building classes, I found that indeed the same concept is used to make classes. So right now we're going to identify classes in a problem. That's the topic of our video. When developing an object-oriented program, you need to identify the classes you need to create. That's quite obvious. How do we do that? Well, one simple and popular technique involves the following steps. You get a written description of the problem domain. In other words, you understand that problem. You identify all the nouns, including pronouns and noun phrases in the description. Each of these is a potential class. You refine the list to include only the classes that are relevant to the problem itself. Once the classes have been identified, you need to identify each class's responsibility. And the responsibilities are the things that the class is responsible for knowing, the action that the class is responsible for doing. Now, nicely said in English perhaps, but let's kind of take a look at this and how we actually do this. We're going to understand that problem first. So we're going to write a description of the problem domain. So you're going to come up with this, or the user is going to hand you something like this, but you need to understand the problem before you can write a description of the problem. We got here. Frank's Auto Body Shop specializes in servicing cars made by Toyota, Honda, and Nissan. The process begins when a customer brings his or her car to the shop. The first thing the employee does is get the customer's name, address, and cell phone. Next is a service quote. The employee determines the make, model, and year of the car and prepares the quote. The service quote shows the estimated parts charges, the estimated labor charges, the sales tax, and the total estimated charges. Okay. Once we got all that, it's time to do a little analysis. We identify all the nouns. We've got Frank's Auto Body Shop up there, specializing in servicing cars made by Toyota, Honda, Nissan. The process begins when a customer brings his or her car to the shop. The first thing the employee does is get the customer's name, address, and cell phone. Next, the service quote. The employee determines the make, model, and year of the car and prepares the quote. The service quote shows the estimated parts charges, estimated labor charges, sales tax, and the total estimated charges. You go through that, identify those nouns, and pop them down on a list. They're all sitting down here. They're the candidates of what we might actually create as the class as we're going into there. Then it's time to take this and kind of refine that list. How do we do that? Well, we cross off any duplicates we might see. So if you got cars a couple times here. What do we got? It doesn't look like too many duplicates. What if we had a bunch? We would get rid of those things. We eliminate what we do not need. Things we don't need are maybe the Nissan. Do we need that? Do we need the Honda? Perhaps not. Then remove the objects that are not classes. The estimated label charges are not classes. The estimated parts charge is not a class. And remove the values that can become variables. Address, name, cell phone. Then you end up with what's left. I've got car down here, I've got service quote over here, and I've got customer down here. Those are your potential classes. And you end up with those classes, those three classes. Now, as you've got those classes, what belongs to these things? It's a lot easier now. You look at the customer class, and it's going to probably involve the name, the address, city, state, zip, phone number, whatever you're going to do, whatever you're going to keep for the thing. The car class is gonna maybe be the model numbers, the make, the year. The service code class is going to contain all the dollars you're going to be dealing with, the parts charges, labor charges, sales tax. So you look back at this list of what you have in here, and you pop them in here, and you end up with the name, address, and cell phone. These become the pieces that belong to the class, the customer class. These become the pieces that belong to the service code class. And these become the pieces that belong to the car class. Now, the customer class is the following action. We're going to create and initialize an object of the customer class. We're going to have gets and sets for the customer name, gets and sets for the customer's address, gets and sets for the customer's telephone number. What does it look like? It looks something like this. You put this in place, and you've got your constructor for the customer, and you've got those variables sitting in here, and you have gets and sets for all of them. Those are the properties that are protected, and you can now use those inside the program you're going to be creating. The car class is the following action. We're going to create and initialize an object of the car class. We're going to get and set the car's make, its model, and its car year. How do we do that? Again, we create a class. The constructor for cars is make, model, and year. As being the pieces that are going to be in there, we'll have gets and sets for all those things, which we can use in the program. What's next? Service code class. It is the following actions. We're going to create and initialize an object of the service code class. We're going to get and set the estimated parts charges, get and set the estimated labor charges, get and set the sales tax rate, get the sales tax rate, get the sales tax, and get the total estimated charges. How do we do that? Once again, we've got all those pieces in here. Parts, labor, sales, total charges. We're going to get, actually, we probably would end up with total charges, probably just make this a get and not a set. Because we're going to be doing the calculations inside here by grabbing the parts charges and labor charges and putting all those things. But we definitely have gets and sets here. So, yeah, this might be a misnomer. This is set right here. So we probably want to get rid of the set here and just give a get here. And that's really basically it. We would have a tax rate, but the tax rate could be inside the program, depending how you're going to handle that thing. But what it does, what this generally does, is you now have 3 classes. Are you correct with these things? Maybe not. Maybe you have to change the stuff down the road. That's okay. You made a good attempt at trying to put down what the classes actually are. And as you begin to develop this program, if you're missing something, you can go back and fix that piece up. What are you left with right now? You're left with the form, which you can actually create the project on. So we're going to have this Frank's Autobody quote system. How it's going to look like? I don't know. That's what you're going to actually go ahead and create down the road. But you do know that it's going to be using the car class, the customer class, and the service code class as part of what you're actually doing. So you end up with this blank, and you look at the code inside that program, it's blank as well, but you've got the 3 classes sitting in there as well. What does that look like in the program? It pretty much looks like this. We've got our form, Frank's Autobody System. There it is, the design of the form. We've got the code for the form, which is sitting over here. We've got the service code class sitting here ready to go. We've got the cars sitting ready to go, the cards class, and the customer class sitting here ready to go. We now can start to program this thing, but we have to design this thing first and what it's actually going to look like. There'll probably be an add button for a customer. You probably have a compute button in there for what's adding all the different parts and all that stuff as you go through it, and then you're probably saving it up to a disk of some kind, probably a database of some kind. And you'll see that down the road as we get into this. But that pretty much is how you identify the classes in a nutshell. This same technique can be used to identify tables in a database. We will actually explore that in the database section of my website. Thanks for watching. Visit the website when you get a chance. And please subscribe to the channel. There's more stuff coming every week. We'll see you in the next video. Take care.